Welcome back, mathematicians. In this video, we are going to learn about the graph of cosine. So what we see here on the graph is that the domain is the set of all real numbers. While there are no arrows on the ends of my curve, there should be, and that means it's going to continue in the same pattern to infinity and also negative infinity. Looking at the range, it consists of all real numbers from -1 to 1 inclusive. So what we see here is that this curve has a maximum of +1 and a minimum of -1. And it will continue in that pattern, so it's going to have infinite maximum and infinite minimum values throughout the course of this curve. So as a result, the range is from -1 to 1. We can write that in interval notation as bracket -1, comma 1, bracket. The amplitude is the height from the center line to the maximum or minimum of the graph. So the center line in this case is the x-axis. I've also heard this called the midline. And so the distance from the center line or midline to the minimum is 1 unit, which is true for all basic cosine functions. And then the distance from the midline or center line to the maximums is also 1 unit. And again, this is true for all basic cosine functions. Now that can change if we have some transformations to the graph or transformations that are being applied to the graph. The period is the length of one cycle of the curve, and the fundamental period for cosine is 2 pi. So for our period or fundamental period, we're going to start by looking at the y-intercept, and that's going to be the beginning of our one cycle. We are then going to decrease to the x-intercept pi over 2 comma 0, continuing to decrease to the minimum, which is at -pi comma -1, then increasing up to the next x-intercept, which is at 3 pi over 2 comma 0, and then finally increasing to the next maximum, which is at 2 pi comma 1. So this curve that I've just outlined, and I will highlight here in orange, is actually the one cycle of the cosine function that usually we would start with. And of course, it will continue on in the same pattern, but starting new cycles or new periods after 2 pi and prior to 0. Let's now look at the equation that represents the graph that we just discussed. So what we have here is y is equal to capital A times the cosine of omega times x plus b. Each element or each variable represents a transformation or attribute that we just discussed. The variable a represents the amplitude. And so in order to find the amplitude, you will take the absolute value of a. When the absolute value of a is greater than 1, it represents a vertical stretch. And when the absolute value of a is less than 1, it represents a vertical compression. Now notice here I never discussed, or in this case we're not discussing when a is negative. A can be negative, but that actually represents a different transformation. Let's now look at the period. So in order to calculate the period, you have to identify omega, which is the coefficient of x. When omega is 1, that means the period would be 2 pi. As a result, there is no horizontal stretch or compression. When omega is not 1, it represents a horizontal stretch or compression, and in order to calculate the new period, you're going to take 2 pi divided by omega. As a result, when omega is greater than 1, it's actually a horizontal compression, and when omega is less than 1, it actually represents a horizontal stretch. Next, let's talk about a reflection. We discussed earlier that a can be negative, and when a is negative, less than 0, it represents a reflection with respect to the x-axis. So again, has nothing to do with the amplitude. And finally, a vertical shift. The constant b represents the shift, and when b is positive, it represents a shift up, and when b is negative, it's a vertical shift down. Let's now use that information to graph the equation y is equal to negative cosine of x over 4 plus 2. So the first thing let's do is identify the amplitude. The amplitude is the absolute value of a. In this case, a is actually -1, so it's the absolute value of -1, which is equal to 1. So the amplitude is 1, and by the way, that is the standard amplitude of your basic cosine or parent function of cosine. So the amplitude hasn't really changed, meaning there is no vertical stretch or compression. Next, let's identify the period. First, it's important to note that when you have x over 4, this is the same thing as 1/4 times x, and that means that omega is 1/4. The period t is equal to 2 pi divided by omega, which is 1/4. Simplifying that expression, what we get is 8 pi. That means that it's been a horizontal stretch. I know this because it went from a distance of 2 pi for one cycle to a distance of 8 pi, so it stretches it out horizontally. Next, because we do see that the value of a is negative, there will be a reflection with respect to the x-axis. And finally, because we have a constant of positive 2, we can see that there will be a vertical shift, and because it's positive, it's going to go up 2 units. We are now prepared to take all that information and apply it to the cosine function. But first, what I'd like to do is go ahead and graph the standard cosine function. And off to the right here, I'm going to go ahead and label the steps that I apply, meaning the transformations that I apply. And the first thing I'm going to do is graph y is equal to cosine of x, meaning no transformations whatsoever. I will start on the y-axis at the y-intercept, which is at positive 1. I will then go to the x-intercept, which is at pi over 2 comma 0, then down to pi comma negative 1, which is the minimum. Next, I will have the x-intercept at 3 pi over 2 comma 0, and then finally I'll have another maximum at 2 pi comma 1. Now I'm not going to connect these, and I will color code everything because of the amount of transformations. We will have a lot of points that are graphed and it will get very messy. So that's why I'm going to color code, and that's also why I'm not going to connect these. Next, I'm going to apply the period. So I'm going to put number 2 and I'm going to write period. And the first point will remain the same because these are affecting the x-coordinates, and if the x-coordinate is 0, it will not change. The last point on the cycle will actually become 8 pi, so you're going to multiply it in order for it to become 8 pi, so I will put it right here. Now I'm going to erase that arrow, and I have to find the other 3 points. Now to find the other 3 points, I'm going to look at the midpoint between 0 and 8 pi, which is 4 pi, and that will become my minimum. So this point then gets stretched out to this point. And then I have to find my x-intercepts. And so the x-intercepts are going to be represented as the midpoint between 0 and 4 pi, which would be 2 pi, and the midpoint between 4 pi and 8 pi, which will be 6 pi. So now we've successfully stretched this out so that the period is 8 pi. So one cycle will be completed with a horizontal distance of 8 pi. Next, I'm going to go ahead and apply the reflection with respect to the x-axis. So I'm just going to put reflection as a note. So that means that every point will be reflected with respect to the x-axis. So this point at 0, 1 will then become 0, negative 1. That means that any x-intercept will actually remain on the x-axis because the x-axis is the line of reflection. The minimum here, which is at 4 pi comma negative 1, will then be reflected to become a maximum. The x-intercept at 6 pi comma 0 will remain the same, and then finally the point or the maximum at 8 pi comma 1 will be reflected about the x-axis and become 8 pi comma negative 1. Finally, I'm going to go ahead and apply the vertical shift. So I'm going to put VS to represent vertical shift, and I'm going to move each and every point that I have in green here up 2 units. So I'm going to move this point up 2 units, and it actually overlaps the point I had prior to this. I'm going to take this point that I have here in blue, which didn't change. I'm going to move it up 2 units. I'm going to take this point in green, and I'm going to move it up 2 units. Then this x-intercept gets moved up 2 units. And then finally, this point in green also gets moved up 2 units. So here's my graph, and so I will go ahead and connect this with a curve. It's going to be very stretched out because of the period change. And again, will look different from the original cosine function because of the reflection with respect to the x-axis. And so there's my curve of y is equal to negative cosine of x over 4 plus 2. All right, guys, good luck.